Hey there, Joel here and welcome to my channel Math World. Today we are going to discuss a very important property which is called as basic proportionality theorem. Before we prove that theorem, I want you to understand what exactly is the theorem trying to tell us. So let's go ahead and see what it is. I have a triangle over here which is PQR, and the theorem states that if a line is drawn parallel to one side of a triangle intersecting the other two sides, then it divides the two sides in the same ratio. And I hope that you are able to understand something here. If not, I'm happy to help you out. Okay, so I've considered this line QR and I'm drawing another line parallel to this line. So my line is, say, okay, over here. Now, if a line is drawn parallel to one side of a triangle, so this is the base of that triangle, one side of a triangle, and I have drawn another line which is exactly parallel to this line. It states that then it divides the two sides in the same ratio. So the other two sides that I have, so let me name these points as point L, okay, and point M. Please stay here. Okay. Now, so it is dividing the other two sides, right? So the other two sides will be this one, PR and PQ. It divides them in the same ratio. That means I can write PL upon LQ is equal to PM upon MR. Okay, is it necessary that this line that is drawn parallel has to be from the midpoints or something? No, it is not necessary. It can be over here, it can be over here, anywhere. Okay, so all you have to remember is a line is drawn parallel to one side of a triangle, then it will divide this upon this is equal to this upon this. That's the basic proportionality theorem. It can be that I can have the side of the triangle as this one, so the parallel line that is drawn will be this way. So here it will be RM upon MP, and say you give alphabet O over here, RO upon OQ. I hope this theorem is clear, and in the next section we will see how to solve it, or rather prove that entire theorem. Okay, so I have drawn a triangle over here, RST, and the line that is parallel is DE parallel to ST. So let us read what is given to us. D and E are the points on side RS and RT respectively. So these are the 2 points which are there on this side. DE is parallel to ST. DE is parallel to ST. EM is perpendicular, that means which forms a 90-degree angle. And DN is perpendicular to RT. DT and ES are joined. DT and ES are joined together. Prove that RD upon DS is equal to RE upon ET. Now in the previous section we have already understood that whenever I draw a line parallel to any side of the triangle, it will definitely divide the other sides in the ratio. But this is a theorem. Now we are supposed to prove that. So how do I start proving? Before I explain you how to solve this proof, I need you to understand how to learn them. It's very important you know the right method of learning it, otherwise it will be very difficult to practice and learn them. In the 9th standard you have studied triangles, you have studied quadrilaterals, and there were so many proofs, and probably either you have left those chapters or you have written them right and practiced so many times till that entire proof is by hearted. I don't want you to by heart the proof. Let us understand how to remember. So first of all, this proof, basic proportionality theorem, it is also called as BPT in short, okay, BPT theorem. And what you have to do is, I have classified that entire proof in 3 parts. So in the first part, we will take this triangle. Okay, so I've written over here. First part, we will take this triangle RDE and triangle DES. I've colored them in 2 different colors so that you can remember. This is the first step. Okay, first step is the main broad step, and not that I will write first step is this, second step, and it's done. First, consider this triangle and DSE as the second triangle. Next, I want you to do is remember this triangle RDE and DET. And third and the final place, I want you to remember this DES and DET. They are all in different colors so that you can remember. Now, this much if you remember, trust me, you're done with the entire proof. What you have to write is what we will see now. Okay, so we have taken triangle RDE. So area of this triangle is given by half base into height. So area of a triangle is given by base into height. Now base need not be always the one which is facing towards the ground, but base can be anything of a triangle. So here in this triangle RDE, my base is RD and my height is ME, because this is perpendicular. So height is always taken perpendicular to the base. So area of triangle RDE is half base into height. That is what is written over here. Why is this? Because it is called as the area of triangle. So I have written the reason for why am I saying all this. Next step, area of triangle DSE. DSE is equal to half base into height. Now, if you remember your 7th standard portion, no matter where and how the triangle is, the height will always be taken from the highest point of the triangle to the base, wherever the baseline is, and it has to be perpendicular. So in this case, this DS, if I extend, it is exactly in line with DS, and this is my height. So area of triangle DSE is half base DS into height ME. In the third step, what I'm doing is I'm taking the first 2 steps and writing them one below the other with an upon sign. So I've taken area of triangle RDE upon area of triangle DSE is equal to, now if I'm trying to divide this half and this half will get cancelled, ME and ME will get cancelled, and what will remain is RD upon DS, which is written over here. This is my, now how how did I come to this conclusion? This is from step number 1 and step number 2. So I've written that as the reason. This is the first part done for the proof. For the second part, again, I have taken triangle RDE. So area of that triangle is equal to base into height. But this time I am taking RE as my base and DN as my height. So half base into height. Reason is area of triangle. And next step, it is DET. This triangle which is in the pink color, okay, is equal to half base as ET, and if I extend this height is exactly in line with the base, right? So height is DN, which is written over here. So area of triangle DET is half base into height. Now sixth step, again we are going to divide this, and so it will become area of triangle RDE upon area of triangle DET. Half and half will get cancelled. DN and DN will get cancelled, and what will remain is RE upon ET. Okay, so I have written area of triangle RDE upon DET is equal to RE upon ET. In the next step, area of triangle DSE is equal to area of triangle DET. Why? Is because triangles on the same base and between the same parallels are equal. You have studied this in the 9th standard. What I mean is, if I have two triangles, this line DE and ST are parallel, correct? And these two triangles, the yellow one and the pink one, that is DSE and DET, both of them lie on the same base DE, and they are between the same parallels. So that means the area of this triangle and this triangle is equal. This is from 9th standard portion. Hope you remember it. If not, I'm just explaining it to you. When triangles are on the same base between the same parallels, the areas will always be equal. Okay, so that is what is written over here. Now once I have written this, now look at this part over here. In the first step, it was area of triangle RDE upon area of triangle DSE was there. Now since I have said area of triangle DSE and DET is equal, all I'm doing is replacing my triangle DSE with DET. Okay, and rest everything remains the same. This is the step number 3 and step number 7. So these two steps help me understand this. Now if you look closely over here, what is happening? This step over here, the left hand sides are equal. Therefore, the right hand side also should be equal. So in the end, what I will get is, one second, RE upon ET. RE upon ET is equal to RD upon DS. And it is from step number 6 and step number 8. And that is what was asked from us, right? So we were supposed to prove that RD upon DS is equal to RE upon ET, that the sides are proportional. And this is the basic proportionality theorem. We have proved it over here. And this is the first proof that I want you all to learn. Please, I request you, write and practice this. Just looking at the video, you will not be able to remember. Take a book, watch the video again, write this entire proof down, practice it, and don't practice writing the same alphabets. All you can do is change these letters to something else and practice the entire proof. The idea remains the same. First, consider this triangle, then this, then again this big triangle, and then this part, and then these two triangles. Remember this much and you will remember the basic proportionality theorem. So again, the theorem says if I draw a line parallel to any side of the triangle, then the other two sides will be always in the ratio. So RD upon DS, RE upon ED. If you like my work, please hit the like button and share this video with your friends so that they also can learn basic proportionality theorem very nicely. And that's it. Take care and God bless you.